Hello class, this is a video tutorial on calculating the volume of prisms. First, in this tutorial, we're gonna first learn what prisms are. Prisms are solids or 3D shapes that have a uniform cross-section along one dimension. Okay, well, it should be one of its dimensions. So I've drawn up 4 examples here, and we are going to determine which of these are and which are not prisms. So first, let's take a look at this idea of a cross section. A cross section means if we were to chop the prism or the shape at any point, what shape will it make? Okay, so now if we take this shape here, and if we were to, let's say, chop it along here that I'm marking. So if we were to chop it along there and pull apart the shape, can you actually see that the shape that it'll make is a rectangle? So yeah, I'll finish off that chopping. Can you imagine that this is what it would look like if we were to chop it? And can you imagine that no matter where we chop it along here, so we could have chopped it here, and it would still have made the same shape all the way through. So if we chopped it along here, the shape would still be a rectangle. So in this case here, the cross section is a rectangle, and because the cross section is the same along this dimension, so no matter where we cut it along this direction, we always get a rectangle. So because of this shape that we have here, the first one, is indeed a prism. Let me just clean this up a little bit. So let me just show you again. If we were to chop it here, we would actually get a rectangle. So this one here is a prism. It's actually a rectangular prism, because it is determined by the cross section that it makes. So the cross section is a rectangle, therefore this is a rectangular prism. Same scenario for our triangle here. So we have a triangle face. You see how no matter where we chop it along this dimension, so if we chop it here, let's make this a little bit neater. If we were to chop it along here, if we were to chop it there, or chop it here, or chop it pretty much anywhere along this line, we get the same shape as we do its original face. So this here is a triangular prism. Let's move on to our next shape here. Once again, if we were to chop this shape along, let's say here, let's say we chopped it along here, the shape that we would make is actually the same as the one that we see in the face. Whoops, a bit more out here. There we go. You see how the cross section of this is actually the same as our face. So as such, this is indeed a prism. It is actually a trapezoidal prism. So because no matter where we chop along here, it will still make the same shape the same cross section all the way throughout this way. Which leads us to our last one. As you can see, this actually isn't a prism, because if we chop it along, let's say at this point, it's a bit hard to imagine it, we get this triangle looking thing. But if we chopped it along this point, it's much harder to see, but we actually don't get the same cross section because this slant is moving inwards. Also, if we were to chop it along this way, we get a square. But if we chop it along a bit further down, we get a larger square. So the cross sections going upwards this way are not uniform. So this is not a prism. This obviously doesn't cover all prisms, because prisms can take a near infinite number of shapes. All you need to understand is that the cross sections must be uniform along one dimension. So if we cut anywhere along here, it's a rectangle. If we cut anywhere along here, it's the same triangle. And if we cut along anywhere here, we get a trapezium. But this is not a prism, because no matter where we cut, we get a different shape. So in our next video, we're going to look at what cross sections have to do with the volume of a prism. Best of luck.